So today, I will be teaching fundamentals of containers, and I will be using two container runtimes. I assume you may never have heard of containers before. Perhaps your colleague said, you need to learn containers. Go join this short course. And you're here and you're like, I don't know. So first, I will explain what containers are from a brand new person's perspective. And then I will talk about Singularity and Charliecloud, the two container runtimes that we'll be using. We will be getting started, meaning that you'll be logging into the ACES cluster to try some exercises. And today we will primarily be working with container images and containers. You'll be actually building your own container images. Sorry, it's a bit confusing, the terminology. The terminology will become more clear as we explain it. So we have some learning resources. Actually, one of these is quite important, which is the first one. We have slides, these slides, the ones I'm showing you now, and they're available on the course webpage. I highly recommend that you open the slides and keep them open in a browser tab. So the link, this same link, is now in the Zoom chat. So I will actually do that along with you so you can see what it's like. If we are at the HPRC homepage and you've navigated to the page for this course, ACES Container Fundamentals or Fundamentals of Containers, then you can, let me make that a little bigger. You can scroll down to find the presentation materials for this semester, fall 2023. That's a PDF which you can open in your browser. Let me make this a little bigger as well. These are the same slides that I'm going through on my slide deck, but I would like you to have them open as well, because there will be times that you want to maybe copy and paste a piece of code that has giving you trouble typing, and you want to be able to move past that, so you can just copy and paste a little bit of code directly out of the PDF into your terminal. So please do keep this PDF open in a tab for reference. In addition to the slides, we have other resources. Our knowledge base has pages for using Charliecloud and Singularity. We also have a YouTube channel with videos, including videos of short courses like this one. And I do recommend perusing the ACES links, which is a curated list of links. Some of them have been added by me. So if you find links in there for learning about containers, then you can be assured that those links will take you to useful resources. Let's learn about containers. Who's ready to learn about containers today? Yeah. What are containers? A container is a process that has its own view of local resources. So examples of local resources: file system, user ID, network, etc. Basically, anything the operating system has control of is a local resource, and you can have different views of those local resources. Today, we're going to be focusing on the file system as the local resource that we're going to be seeing different views of. Containers can modify your view of other resources, but we don't have time to learn everything today, so we're focusing on the big one. So a normal process, represented by this gear, would see the physical file system represented by this disk, and it would be able to read the files that are on that file system. But suppose a sector of that file system is itself a representation of a smaller file system. We call this an image. Then the container would be a process that sees the image instead of the real file system, as though the image were the real physical file system, and the container does not see the rest of the real physical file system. So the word image here comes from way back when disks were literally spinning circles and they were optical. So data on disk was literally an image. If you had a microscope, you could see it. Why use containers? Containers are shareable. You can share your container image file by uploading to a public repository, and you can use images that are shared by others. Portability. You can use images on any computer with the same architecture. So the architecture we have on ACES is x84-64. This is the architecture that is supported by Intel and AMD, who are the two largest manufacturers of chips for Linux servers. The other main architecture you sometimes see is ARM. ARM is used by Macs and a few other smaller devices. I don't think we have any of those on our cluster today. So all the images on our cluster today should work on all the machines. Reproducibility. Container users are largely unaffected by changes to the cluster environments. So if you are a scientist and you wish to do science, then a principle of science is that at a later time, someone should be able to reproduce your work. If you have some software and the software has dependencies that are maintained by the local system administrator, and the local system administrator decides to make some changes, your software can stop working as intended, and it can be very hard to reproduce your prior work. Keeping your software in containers means that you're largely unaffected by changes to the cluster environment, so it's relatively easy to reproduce past work. What goes in container images? So a similar concept to a container is called a virtual machine. In a virtual machine, the operating system kernel is in the image. In order for the operating system kernel to function, we need to emulate some hardware. So the virtual machine manager is emulating hardware that the guest operating system kernel thinks it's in charge of. So a virtual machine are commonly used for things like web servers, where the process, there's only one process and it just waits for it to be needed. But sometimes in the scientific applications, you want to have a lot of processes running on the same machine, and it's very difficult to have a lot of virtual machines running because they're large in memory, because each one has its own operating system kernel. So in order to save on memory, the process, the principle of containers is, let's not duplicate the operating system kernel. Let's just use the operating system kernel that's already there, and then the container will just have the files that make one Linux distribution different from another. So all the Linux distributions that share the same kernel will just be compatible. We won't duplicate the shared element. So that's the power of containers, is because all the flavors of Linux on the same architecture can use the same kernel, we don't have to duplicate that. So containers are much smaller in memory. Are there any questions about virtual machines versus containers? There's a lot of words on the screen. All the green things are lumped together as things that you can put in a container, basically. What is a library? What is a binary? What is a user application? The libraries are essentially the things that make one distribution of Linux different from another. So these would be things like libc, which is the C compiler library that many executables need in order to function. The guest binaries would be the applications that come with each distribution. Lots of distributions come with their own applications. Things like the bash shell that we use to manipulate files. And then there's the user applications, which is whatever you want to install on that operating system. Popular container runtimes. So containers have technically been around for a while. LXC was the first functional container back in 2008, but aside from some extreme Linux nerds, no one really knew about it. It wasn't until Docker in 2013 that containers really took off. Docker is heavily used by scientists in a variety of fields, even today. However, Docker is not perfect. It does have some problems. Namely, Docker is not compatible with principles of high-performance computing clusters, such as sharing nodes with other users. In order to use Docker, you need to have root permission to launch the Docker daemon, and we can't give root permission to users who are sharing nodes. So Docker is simply not available on basically any HPC clusters. In order to make containers available on HPC clusters and other environments, we have a variety of other container runtimes that have been created since then. Singularity was one of the first successful container runtimes to operate on HPC, and we're still using it today. Shifter is a thing that exists, although we don't have it on our cluster. Charliecloud, a relatively newer runtime, does many of the same things Singularity does, so we'll be learning that today. And Podman, one of the newer runtimes, Podman is basically Docker, but with less of the problems of Docker. So it's not specifically for HPC. You can run it on HPC, but it doesn't have the background of being designed for HPC like these other runtimes. So we won't be learning Podman today, although it is an option. It does function. I have a question in the chat. If I have an x86-64 container running on an HPC that initiates a window on an ARM Mac, is that an issue? I'm sorry, Mr. Farmer, I do not know the answer to that question. As far as I know, that's not a problem because X11 protocols are, let's see, those happen at the X11 protocol is handled at the distribution level, not at the kernel level. So I think probably your Mac is going to be running a version of X11 that's compatible with whatever's on HPC. I haven't tested every possible combination, but as far as I know, that's not a problem. And we do have examples of running windowed applications on HPC remotely, both over SSH and in the browser. And we have examples of those running both on bare metal and in containers. So generally speaking, this is a solved problem. I just don't know every possible combination that could happen. So I'm going to talk about Charliecloud first. There's really no particular reason. Charliecloud and Singularity are both container runtimes. I just have to do them in some order, and Charliecloud's first. So what is Charliecloud? Charliecloud is a lightweight, fully unprivileged container solution. Charliecloud's motto is small software delivering big flexibility to HPC, and Charliecloud is developed by Los Alamos National Laboratory. So what does it mean for it to be lightweight? That means Charliecloud is, it has not as many features. It's meant to be more of a do-it-yourself type of solution where it provides the minimal core features and then the user is expected to either fill in the blanks with other Linux tools, or at least be educated enough about containers to be able to put together the rest of the solution. So if you're doing something that is quite novel or personal, Charliecloud is a fine choice because it doesn't hold you back from doing things your own way. But the downside is it doesn't have quite as many features, so some things may be a little harder because Charliecloud doesn't do those things for you. Now, the fully unprivileged part is important because on HPC, of course, if you have to ask your administrator to install something, it's going to slow you down. With Charliecloud, you never have to ask your administrator to install something, so users can do their total workflow autonomously, and that means they can research at the pace that's comfortable for you. So what features does Charliecloud have? So Charliecloud is a container runtime and an image builder. That's important because if you can't build images, then there's not much use being able to run images. Charliecloud can read and convert Docker images. Recall earlier I said Docker is the most popular runtime because it's been around the longest. So a lot of images that are available in repositories are in the Docker format. And that's not a problem for Charliecloud. So you can take advantage of, the decade of container development that is already on the internet. With Charliecloud, the file system inside the container is isolated. So you can't accidentally break the host file system. Other users can't see your files inside the container. And we have a well-maintained security boundary. And the reason the security boundary is well-maintained is because Charliecloud actually doesn't maintain it. Instead, all of the work of maintaining the security boundary is delegated to the Linux kernel. Let the Linux kernel do what it does best. That's Charliecloud's motto. Similarly, the user inside the container is isolated. So outside the container, you're a regular user, but inside the container, if you want to be the root user, that's no problem. You can be any user you want. And that won't affect what's going on the real physical operating system, because there is a map between what the user is inside the container and the user outside the container. Charliecloud works with high-performance cluster technologies such as InfiniBand for data transfer, NVIDIA GPUs, and the reason it can do this is because it is minimal. It doesn't attempt to translate your container's language for these things, so your container has access to whatever drivers it needs in order to operate with let's see, your container all generally has access to the same hardware on the local node. If it can find the correct drivers, it can operate those hardwares. We can read more about Charliecloud manual on GitHub. There's a link here. We won't need to do that today, but I do recommend perusing it on your own time because the 90-second tutorial on Charliecloud is quite good. Now, on the ACES cluster, we have Charliecloud available from our module system. If you've been on a cluster before, you probably recognize module load. So in our cluster, it's just module load Charliecloud. You can specify a version, or you can just get the latest version. Charliecloud images can be large on disk, so you need to be aware of your storage quota. Now, you have two file areas. You have a scratch file area and a home file area, and your scratch quota is much larger. So whenever we are putting a Charliecloud image in one of those, we're going to prefer to put it in scratch rather than home. Next, some container activities may be too CPU intense for the shared login node. Be courteous to others and use a compute node for large image operations. We will show you how to use Charliecloud on the login node and on the compute node. So you will understand the difference. Some container activities may be too I/O intense for the shared network file system. So both of these network file systems, Scratch and Home, are Lustre on the back end at the ACES cluster. So they don't do so well for intense I/O. So it's better to use a local file system that's specific to a given compute node whenever you're doing intense I/O operations. And then after you're done, you can copy the result over to the Scratch file system, which will be a less intense operation. Let's talk about Singularity. So Singularity is an easy to use high performance container solution. Unlike Charliecloud, Singularity is trying to be as featureful as possible. It wants to help you do your work so that you don't have to think about tedious things like, how do I get access to the hardware? Singularity wants to give you access to the hardware automatically so that you can concentrate on what matters to you. So the downside of being easy to use and featureful is that if you try to color outside the lines, it gets a little bit harder because you're kind of fighting against what's already there instead of just being invited to do your own thing. Now, there's nothing wrong with one strategy or the other. It could be a matter of preference. Singularity and Charliecloud are both totally capable of doing all container tasks. But one of them is more try to do things for you, and the other is try to let you do things on your own. So the Singularity motto is deploying secure container solutions from edge to exascale, and it is created by Scilabs, which is a private corporation. Tiny history lesson, Singularity is aptainer. What does that even mean? Why do I have two words? Once upon a time, the corporation Scilabs created a product named Singularity. But no, that's a bad business model. Instead, let's have tiers. So there's the free version, the enterprise, the pro, the container services for even more possibility for revenue. And if you're a company that wants to do a lot with containers, you probably do want to pay Scilabs for their services, which I assume are high quality services. But wait a second, Linux Foundation heard someone say the word free. CE here stands for Community Edition. That's the free version of Singularity. So Linux Foundation is like, did someone say free? Don't mind if I do. And they have a fork that's Git language for an identical copy, but it's named aptainer because it's not related to Scilabs making money. Instead, it's just for everyone to freely use. The code underneath is the same as far as I understand. It's just a matter of branding. Do you want the free thing from Scilabs or do you want the free thing from the Linux Foundation? So sometimes you'll see Singularity, sometimes you'll see aptainer. It just depends on what the local site administrator decided to go with. Singularity features. Singularity is a container runtime and an image builder. Well, that's the same thing I said about Charliecloud. Singularity can read and convert Docker images. That's the same thing I said about Charliecloud. The file system inside the container is isolated. That's the same thing I said about Charliecloud. And oh, here's something new. The user inside the container is the same as the user outside. Charliecloud's philosophy is to keep things more simple. So inside the container, you're the same user as outside. You're not the root user inside the container, you're just your normal user. So that makes it easier for system administrators to keep track of things like who has permission to use what resources at what time. So integrating with Slurm or whatever is a bit easier on the back end. Now, for the user's point of view, user IDs rarely matter to you, so you probably can't tell the difference. As long as you can do your work, what does it really matter what your user ID is? So this is, from your perspective, just a preference thing. But yes, you can still get your work done. It's just a different philosophy. The Singularity works with high-performance cluster technologies, but this time for a different reason. Singularity works with HPC because Scilabs worked hard to integrate Singularity with the HPC drivers so that you can automatically get access to your GPUs and your network cables for high performance cluster activities, because Singularity has done most of that legwork for you. And that's one of the advantages of doing business with a corporation like Scilabs, is they've invested a lot into their product. You can read more in the Apptainer manual. You can read the Singularity manual as well. As far as I know, they're pretty much the same thing. I just have a link here for the Apptainer manual. I believe this is the version we have on our cluster. It might be slightly out of date, but the information should still be good, or you can just go find the latest and make sure you're reading the latest. Singularity on ACES. Singularity is available on compute nodes. Historically, Singularity activities were too CPU intense for login nodes, so it's just not available on login nodes. That's okay, we'll show you how to get to compute nodes. Singularity images can be large on disk. That's the same thing I said about Charliecloud. Images are images, so we're going to put them in Scratch and not in home. And once again, the container activities may be too IO intense for the shared network file system, so we'll use a local file system for the largest of the image operations. But again, I'll show you how to do these things, so it will be familiar by the time we get there. It has been 30 minutes. It's time to get started. Who is ready to try your hand at some container activities? I'm excited. Containers are amazing. So in order to use the ACES cluster, today we'll be using the ACES portal, which is the only currently supported way to get to the ACES cluster. So how do you get to the ACES portal? You can navigate to its URL in your browser. I'm certain that somebody will drop this link into the Zoom chat any second now. It was me. I dropped that link into the Zoom chat. Or you can navigate to that same link through our webpage. Our homepage has a bar at the top with a navigation bar, and under the portal menu, one of the options is the ACES portal, parentheses access, because we use the access authentication method, so all access users can have access to the ACES portal with any valid allocation. So if you registered for this course, you should have a valid allocation, and you should be able to log into the ACES portal. So let's give it a try. I'll work right along with you. Exit full screen. HPRC, portal menu, ACES portal access from the portal menu. Oh, so I logged in earlier and it remembered my token. I'm going to try to log out and see if I can get it to show you what the login screen looks like. Nope, doesn't matter. Even if I click log out, I still get right back in. Okay, well, that's funny. I guess I could do it in another tab, but that's kind of unnecessary. I have a screenshot of what it's meant to look like. So we'll just go back to the slideshow. So if you haven't logged in recently, you'll see the access authentication page. And if you registered for access using your institution, which I do recommend, then you'll pick your institution from the drop-down menu, and it will redirect you to your institution's single sign-on. If you didn't have an institution single sign-on at the time that you registered, then you would just use the Access CI's built-in sign-on, which would then look like this. So you either get this one on the right if you're like previously an Exceed user and you didn't have the institution method available, or if you did register with an institution, then you'll see your institution's single sign-on instead. So once you get to the ACES portal, let's make sure I'm still on the ACES portal. Yes, so I'm on the ACES portal. I will make it a bit bigger. Once you get to the ACES portal, I would like for you to throw the thumbs up in Zoom so that we can see that you're following along. This is probably the most important step, is making sure that everyone can get access to the cluster. So I will pause here for a moment and make sure that lots of people are getting access to the cluster. Euron asks, what is bypass code? That sounds to me like the two-factor authentication for your institution. Many institutions have two-factor, and I believe we, Texas A&M, require you to have two-factor turned on in order to have an account on ACES. So if your two-factor is turned on, then you'll have to use it. So that's whatever two-factor your institution already provides. While we are waiting, I think I'd like to show something that's not in my slide deck, but maybe of interest to you. It can help with our exercises. For our exercises, we'll mainly be using the terminal that you get to from the clusters menu. But there are a few points where it's actually helpful to look at the files in a file system navigator. So we actually have a file system navigator provided by the on-demand framework. So if you click on the Files tab, you can take a look at your home directory or your Scratch directory. We're going to be using Scratch today, so let's take a look at a Scratch directory. So here we have a file navigator. Here are some of my files. And you have some options like new file, new directory, upload, download, copy. So these can more conveniently help you to manipulate files, which we will need to do a little bit of in order to do our exercises. So for example, there will be a point today where I need to create a directory. So if I come over here to this file navigator, I can create a directory. How about a container tutorial directory? So I create that, and there it is. Now I can navigate to it and see that there's nothing in here. How about a new file? Example file.txt. How about if I edit the file? So you can go 3 dots, edit, and you get a lightweight text editor, and it can do syntax highlighting for common programming languages like Python. So you can go in here and say, I want the Python syntax highlighting, please. So you can do like import numpy, print hello. You can see that it's highlighting the syntax with awareness that this is Python language. Or maybe some, maybe if it's a batch file. What's a batch file? Is this shell in the menu? Ought to be some kind of shell in here. SH, I think that's shell, right? So that would be like, what's an example of shell? We have like echo, hello. Yeah, there we go. That looks like shell, doesn't it? What else is shell? Maybe a redirect operator. Yeah, so you can have some shell syntax highlighting. So I don't need to save this, but you would click save if you wanted to save it. I don't need to. I was just playing around, showing you an example of how it is convenient to work in the file navigator to manipulate files for some cases. Okay, I believe I have waited long enough that, oh, Mohammed asked a question. Can I access with Exceed account? Exceed account should work, but you might have to migrate your Exceed account to an access ID in order to be allocated to the cluster. I'm not familiar with if the Exceed interface would have allowed that or not. By the time I joined this, Exceed was already being phased out in favor of Access. So I don't know all the details about migrating. But if you've had an Exceed account, you should be able to migrate to the access CI interface and still do your work. So to do our exercises, we need a shell on ACES. So in the on-demand portal, the navigator at the top has a clusters menu, and the only option currently there is ACES shell access. So please click on it. So I'm going to click on clusters ACES shell access, and it pops open a new tab and drops me into a login node. Is this big enough? Should I be making this bigger? Maybe a little bigger. Is this big enough? You all hopefully can read the terminal on my screen. So I landed on ACES login 1. ACES has 3 login nodes, and you will randomly get one of them. That could matter because, as we previously discussed, we will be using the local file systems for some of these activities. So local file systems are node specific. So if you're in the middle of an activity and then you get interrupted and you try to return, but you end up on a different node, you basically will have to start that activity over, which isn't not the worst thing, but it's something to be aware of. So do be aware of what node you're on, because there are some node specific activities due to the local file systems. So success, welcome to the ACES login node. You can see last time I did this, I took a screenshot. I was on ACES login 2. This time I landed on ACES login 1. Would anyone like to share in chat which login node you landed on? Did anybody land on ACES login 3? Yep. Some people landed on login 3 and 2 and 3 and 2 and 1. A pretty wide variety. So we're going to do both Charliecloud and Singularity today. I have to do them in some order, so we'll do Charliecloud first. We can do Charliecloud on the login node, so we're on a login node. Let's do some Charliecloud. You need to execute module load Charliecloud module list. These are easy enough to spell. I think you probably should just type them on your own for practice. Module load. Actually, I'll do clear. Module load Charliecloud module list. Currently loaded modules Charliecloud /0.33. 0.33 is technically not the latest because 0.34 was released like a couple weeks ago. So you could have 0.34 if you wanted it. It's available, but we haven't installed that centrally yet. I'm sure we'll do that soon enough. Particular versions of Charliecloud have some small incompatibilities. So it is better to stick with the same version unless you want a feature that a newer version provides, which you do because the features are good. So yes, you should still upgrade. Just be aware that when you upgrade, you might have to rebuild some of your stuff. So Charliecloud provides several executables. The first one we're going to use today is chimage, ch-image. So let's check that chimage exists. Oops, clicking on the wrong thing. So chimage tab autocomplete is your friend. So chimage says it has many, many options. We're not going to have time to talk about all these options today, but one of the things it can do is fetch images from the internet. And the option for that is chimage pull. So chimage space pull, that's an option that says, please go fetch an image from the internet. Now, we didn't type a URL in this example. It says Alma Linux 8. So what's the URL? That would be the default URL for images in Charliecloud, which is Docker Hub. Anybody heard of Docker Hub? Google Docker Hub. This is Docker Hub. That's where a lot of images live on the internet. So by default, that's where Charliecloud is going to look, because this is where probably a majority of images live on the internet. So in particular, Alma Linux. Alma Linux is a distribution of Linux that is small. Let's read about it. Alma Linux. Alma Linux is the official build of Alma Linux operating system, which is a Docker official image. So in other words, Alma Linux was specifically created to live in containers. It's lightweight. So the benefit of a lightweight distribution is it's smaller in memory, which is perfect for containers. So Docker has an official build of Alma Linux for containers. So let's do the exercise. CH image pull Alma Linux :8. Oh, storage directory seems invalid. That's because I previously used a different version of Charliecloud on this node, and the storage directories were incompatible. So that's okay. I'll just clean it out and start over, which is what I wanted to do anyway. Let's try that again. CH image pull Alma Linux 8. It says it's done. So that took about, what, 15 seconds? It's not a very big distribution, only a few megabytes. Everyone, please do take a moment to do this exercise. If you are following along in your copy of the PDF, we are on page 25. So you can copy and paste the words from this PDF directly into your terminal. The terminal app in On Demand does support copying and pasting from your normal OS hotkeys, like Control-V if you're on Windows, for example. So CH image list tells us that we previously downloaded Alma Linux 8. Here's an interesting question. Sorry, I just need to get some of these tabs out of the way. Shoo away, tabs. Here's an interesting question. Where is the image? Charliecloud puts the image in a temporary local image repository, and the location of it is in this variable, ch image storage, which is a variable that points to your local image repository. So let's see where it is. It says it's in the temp file area, and its name is my username followed by .ch. The temp file area is a local file system, so it's node specific. It's also a high-speed file system, so it can handle these I/O intense operations, like pulling many files from the internet and combining them and doing tarball things. These are I/O intense, so it's perfectly fine for the image to live there. Let's take a look at the image. So it suggests using ls to explore that directory. ls ch tab autocomplete. We have some directories. One of them is named image. And in the image directory, we have Alma Linux 8. So that's where that image lives on disk right now. When we pulled it, it put it in this temporary local repository, and there it is. Was everyone able to download the Alma Linux 8 image and find it on disk on the local file system? Please throw a thumbs up in Zoom if you have managed to get that far. Thumbs up, thumbs up. Very good. Now that we have an image, what can we do with an image? We would like to launch a process, right? We would like to launch a process that has a different view of the file system. So that means we need to compare the two views of the two file systems. So first, let's investigate the local file system on the real local file system on the node. So the ACES login node has Red Hat Enterprise Linux installed. So that means there's a file at etc. Red Hat release that knows what version of Red Hat is installed. So if I copy this, we can see that on the login node, we have Red Hat Enterprise Linux release 8.8. And how do we know? We know that because we have done, that's what's in the file, etc. Red Hat release. But what if we had a process that was looking at the image and thought that what was in the image was the local file system? Well, Charliecloud has a chrun executable that can help us with this. Chrun -- help if you're curious. I'm going to skip that step from now, and I will just show you the next thing. Let's launch a bash process that thinks Alma Linux 8 image is the real local file system. So that's chrun space, the name of the image. If you don't provide a path to the image, then it assumes you mean one that is in that temporary local image repository chimage storage. So that's what it understands by default. So chrun, that same image we just pulled, and then the name of the process, bash. Chrun Alma Linux 8 bash. And now I have a new terminal. You can see that my prompt changed. It used to say username node $. Now it just says bash $. It's still a bash terminal, but something is different. So that's your first hint that now we have a containerized process. Now that we have a containerized process, let's investigate the local file system. As it turns out, Alma Linux is also a variant of Red Hat, so it also has a Red Hat release file, but with different content. This file system has a file, etc. Red Hat release, with the content Alma Linux release 8.8 Sapphire Caracal. The file has the same path, but it's a different file, because in the container process, we're not looking at the real file system. Now we're looking at the file system as in the image. But now that we're in a container, are we still on the same node? Recall before we did host name and we learned we were on the login node. Does that still work? Yes, it does. We're on the same node. So the underlying hardware has not changed. The underlying Linux kernel has not changed. All that has changed is the files that are specific to this Linux distribution that live in that image. Whenever you're done running your bash terminal, you have to exit your bash terminal. So we're just going to use bash's exit function to return to the regular file system. So instead of this containerized process seeing the images file system, we're now back to the regular login that sees the regular file system. I'm not seeing any responses, but I do see some thumbs up. So it looks like people have done this. Let's take a look at Singularity. So we looked at Charliecloud. Let's do the same thing with Singularity. Now, I said Singularity is only available on the compute nodes, so we have to get to a compute node. In order to get to a compute node, we use Slurm. We're going to do this interactively, so we have the srun interactive variant that goes srun pty bash I, which is I would like a login on a compute node, please. But because Slurm on our cluster requires you to request a time and a memory, we're just going to have to provide those. So I'm going to try and copying and pasting out of my PDF because I would like to know if this works, at least for someone. So srun time 90 mem4g pty bash I. Job queued and waiting for resources.
Yeah, that's what I had.
Okay, so it seems like lots of people are queued and waiting. So let's figure out what's going on in Slurm. I'm going to open up a new cluster terminal. And let's take a look at what's going on with the compute nodes. So we have some reserved nodes. We have some idle nodes. Somebody's using these nodes. Here we have some more idle nodes. CPU star. They are in the CPU star partition. S control show partition. So CPU max time 7 days. CPU node partition on. State equals up. Okay, so far so good. S control show job. What's my job number? 6471. Pending reason priority. Let's take a look at what jobs there are. So we have a bunch of running jobs that are on CPU nodes and some pending jobs that want a lot of CPUs. So this user apparently wants to use several nodes on the cluster. And this user, these users want to use some nodes on the cluster. Oh, that's us. That's us. I see us. There we are. Hi. So it seems that this user has priority on getting access to nodes. That's a bit odd because this user requested 4 days and we only want an hour and a half. I wonder if there's anything we can do about that. Max config. That is correct, Delilah. We don't have a reservation because we don't need any particular nodes. We just need any compute node. So I did not expect we would need a reservation to get to any compute node. It's just bad luck that we had some users using lots of nodes all at once. Usually this wouldn't have been a problem. If we needed to, oh, look at that. My job finally reached a compute node. Would anyone else like to throw up a reaction in Zoom if your job finally reached a compute node? Somebody said yes. I see a thumb and a thumb. Yes. Okay, so you finally reached a compute node. Thank you to our system administrator, Francis, for rescuing us and helping us to get access to the cluster today. Thank you, Francis. What was it we were meant to be doing? Oh, yes. So let's check what node we landed on. I landed on node AC91. So what kind of operating system is on AC91? We can check. Let's cat the etc. Red Hat release file. Red Hat release 8.6. So that's slightly different. If you recall, I think the other one was 8.8. Still a Red Hat, but not exactly the same. Now, in order to set up Singularity, now Charliecloud automatically knew where to put your temporary repository, but Singularity does not, so we have to tell it. So we export the Singularity underscore cache dir, and we set it equal to the $TMP_dir. I do recommend copying this line out of your PDF because it is a bit long. Let's just talk about that and make sure we understand. So Singularity cache dir is now in the temp file system at temp dir. Oops, copied too much. Temp dir is a location in the temp file system that's specific to this job. The benefit is it gets cleaned up automatically when we're done. So that's why I like to do it. Did we want to purge Charliecloud from module list? Good question. Do we still have Charliecloud? I do. So I guess I would like to remove that. When we loaded Charliecloud, it would have set up for Charliecloud on a login node. We're now on a compute node. Technically, it's better to reload Charliecloud. And then, so the next thing we need is module load web proxy. And if we want Charliecloud again, which we will later, we need module load Charliecloud again. But when you load it on the compute node, the result is maybe slightly different. So now we have module load web proxy and Charliecloud again. Even though it looks the same, the result is slightly different. How do we know the result is slightly different? Let's look at that ch image storage. See, it's a different directory because on the compute node, we use the temp dir variable to set your image storage, so it gets cleaned up automatically after your job. But in order to get set that, we have to reload Charliecloud. Good question, C. Roberts. We were going to have to do that eventually, so we might as well do it now. So what were the steps? Get to a compute node, export Singularity cache dir. That's important, and module load web proxy. Everybody was able to do those 3 steps? So we're currently on page 27. I'm about to go to page 28. Okay, so let's use Singularity to get a shell in the Alma Linux container. We previously did this with Charliecloud. Now we'll do it with Singularity. So Singularity is more featureful than Charliecloud. So Singularity can do this cool trick where it fetches an image and launches a process all in one line. The syntax is a little different. Instead of Singularity run and then specifying, it was ch run and then you specify bash for your shell. Here we're going to do Singularity shell, but we're not going to specify which shell, and Singularity will figure it out. So Singularity shell, and unlike Charliecloud, Singularity does not have a default URL, so we will have to specify Docker. Now, thankfully, once you tell Singularity you wanted Docker, it does know how to find Docker. So we just have this shorthand URL for Docker means, dockerhub.io or whatever it actually is. So Singularity shell, docker :/ and then the name of the container image, Alma Linux :8. And that will both fetch the image from the internet and launch the process, the containerized process at the same time. So Singularity shell, docker : Alma Linux : 8. downloading, 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 harmless warnings that don't matter, creating a file. We'll learn more about that file later. Don't worry, I will tell you about that file later. Okay, and now we have a prompt. It's not the same as it was before. It used to say login node. It used to say user compute node $. Now it says Singularity caret. Yes, Mayra, we will learn to build a Singularity image. That's one of our exercises later. That is one of the things that I intend to teach you today, assuming we don't run into any more of these technical difficulties, which unfortunately do sometimes happen. So we have this prompt now, Singularity caret. It's not the same. Is it really a bash prompt? I claim that it is. How do we know? Let's try some bash things. Cat, etc. Red Hat release. Yes, so this is the Alma Linux release 8.8. So just like with Charliecloud, Singularity now has a shell that sees the image as though the image were the real file system. And whenever, and again, we should be able to check the host name and see that we are still on a compute node because it's the same hardware. And whenever you're done with your shell, you use the bash exit command to leave that container and return to the normal process that's just seeing the real compute node. Has everybody had a chance to do this? Please give a reaction in Zoom if you've had a chance to do this. Are there any questions about the Singularity shell or the Charliecloud shell that we already did? Obviously, there are more things that we'll have to do, such as build images. I would like to know if there's any questions about what we've already done.
Where's the image was downloaded?
How do you return? That's a good question, C. Roberts. Let's try it. So if I hit up on my keyboard, I can cycle through previous commands, and there's Singularity shell Docker Alma Linux. That's what we ran, right? That did the download step. What happens if we run this again? Watch carefully. Using cached SIF image. In other words, because like Charliecloud, Singularity keeps a local image repository, it knows it previously downloaded this, so it's not going to download it again. It says, oh, I already did that. I'm just going to use what I have. And we drop directly into the shell. So doing this strategy, you only download the container image if you need it because you don't have one. If you already have one, then you don't have to download it again. Now, to be fair, I did tell you that we told Singularity to put its cache here. In the temp file system, which means this temp file system will be deleted once our job stops. In fact, the next thing we're going to do is stop the job. It says, don't forget to return to the login node. So we're currently on the compute node. We need to return to the login node, the exit command. Now that we're on the login node, this area obviously doesn't exist because that area was specific to that compute node. So now that we've left the compute node, we would have to re-download that image because that compute node directory will be cleaned up after the job ends. Thank you for a good question, C. Roberts. Congratulations! Welcome to containers. You can now do the fundamental task of fetching an image and launching a process. I'm very excited for each and every one of you to join the wonderful world of containers. Now, unfortunately, thanks to our technical difficulties, we're already an hour and a half into this short course, so I think it's time for a break. I'm going to call for a break at this time. Howdy, students. Welcome back from your break. I hope you feel thoroughly refreshed and not at all discouraged by the plague of technical difficulties that have been occurring so far. Let's learn something new. Let's learn working with images. So far, I've just showed you the default place the containers put images. Let's learn how to put images where we want. That means we need to know about image formats. I'll start with Charliecloud. Charliecloud container images come in two main formats. First, we have the directory image format. And second, we have the single file image format. And for this purpose, HPRC supports the squashfs file system format for single file images. We'll learn more about that on a later slide. Charliecloud has a tool, chconvert, that can copy images into different formats. So let's try the chconvert tool. In order to create a directory image, the image name should end in a slash. So that's your hint to Charliecloud that you are trying to refer to a directory format image. The benefit of directory images is that they are writable. However, directory read-write operations are slow. So we want to put directory images on the high-speed temp file system, not on the network file systems. I would also like to note that images in image storage are also directory images under the hood, but those ones you refer to by their name without the trailing slash. You're supposed to pretend like you don't know they're directory images because manipulating them directly is not supported by Charliecloud. If you want to play with those images, you need to copy them somewhere else, or otherwise Charliecloud will get mad at you. So that's what we'll do. Let's make a space on the login node for yourself. You are allowed to use the temp file system for your purposes. Just make a space for yourself. So mkdir temp, and then user is your username. So that's how you know it's a space that's for you. Then let's convert our image that's in the cache to a directory image. That means chconvert source image and then destination image. So the source image is ALMA 8 with no trailing slash, which means we're referring to an image that's in Charliecloud's image storage local image repository. And the destination argument is a path on disk that ends in a slash. So we are telling Charliecloud, please put the result here and have it be a directory format image. And once we have done that, we need to hit it with ls to see what we made. This is a bit longer, so I wouldn't fault you if you wanted to scroll down here through the slides and grab a copy. So where am I? I'm on the login node, right? Everyone should be back on the login node because we did exit. If you're not sure, host name, a login1.cluster. If you're still on a compute node, please exit the compute node and return to the login node for this exercise. So let's mkdir temp/user. Oh, I already have one of those. My bad. Yeah, so I already have one of those and I've been putting things there already. So you can see I put a Docker image there. I put a Jupyter image there. Like that's my personal stuff. The temp file space on the login nodes is like semi-persistent. It doesn't get wiped out every time you log out, but it will get deleted eventually. Like the sysadmins come through every few weeks to clean it out, I guess. I don't know exactly what the lifespan is, but at least it's long enough that you do your work over the course of a few days. So what are we doing? Let's make an ALMA Linux directory image using chconvert. Okay, it said done. It only took a moment. And let's hit it with ls to see what's there. What's there looks like a Linux root file tree. Does anybody recognize this as the root of a file system in Linux? That's because directory format images are just the root of a distribution's file system. Jose would like to remind us where the slides are. Thank you, Jose. Marco, please do follow along by opening up the slides if that is of benefit to you. What is the ownership of these folders? That's a good question. Let's hit it with LSL. It says they're owned by me. So these are just ordinary files on disk owned by you, because Charliecloud is the what? Fully unprivileged container solution. So every file you make with Charliecloud is just a regular file owned by you. Why don't we try to do something with this directory format image? I said earlier that directory images are writable, so let's write to it. We need to get a process that's running, a container process that's running out of that image, and then from in the container, try to modify the image. In other words, try to modify the root file system tree from inside the container. That's what we're trying to do with this exercise. So we are going to do chrun with the name of the image, but this time it's path on disk for the name of the image. And then the executable will be bash because we just want to do some file system things. So let's grab some of these lines and see what they do. Oops, I clicked the wrong button. So chrun -- write temp user alma Linux bash. Oops. So now I would like a bash shell that thinks that that image is the root file system. So if I go ls, there's that root file system. Let's add something to it. mkdir mir. And yep, there it is. So I added something to the root file system. And then I'll leave the container. So how do we know that the changes are still there? Let's go back into the container and see what the root file system looks like. Yep, that directory is still there. So changes you are making when you have the write flag on are persisting. Is anybody curious to know if that folder ended up somewhere inside our image? In fact, it did. It's here. You might say, well, Richard, if all you did was put a folder here, you could have just done that manually. Yes, but the point is, eventually we're going to be doing stuff that's a lot harder than creating a directory. We're going to be doing stuff like installing software, which you definitely should not be doing manually. You will give yourself a major headache. You're trying to install software libraries by manually inserting one file at a time. So I'm not going to teach you how to do it that way. I'm going to teach you how to do it this way. This way is more, how do you say, sustainable. So are there any questions? Yes, please do ask your question.
You were on the login node. You are not into a compute node anymore.
At this moment, I'm on a login node. We left the compute node to demonstrate the difference between the compute node and the login node. We'll get back to the compute node for the soon.
I thought we are doing the conversion on the compute node temp directory.
We can do conversions, and we'll do one later, but this one is fine to do on the login node because it's very small. Mayra asks, if you re-download image under another name, the new dir won't be there, correct? Well, we already have the image under another name. We have chrun alma linux 8, which is the original copy that's in our temporary area that Charliecloud owns. This copy didn't get the update. You see, it doesn't have my dir. And yes, if you re-download it, it still won't have that. I'm trying to make it so that these aren't so mysterious. They're mostly just regular files once you start to understand them. Do you feel okay to move on to the next image format? Any more questions about the directory image format? Let's learn about the squashfs image format. Squashfs is an open source file format for file system images, not just for containers. You can also use it for like disk images. In squashfs, the whole file system becomes one single file. So the file should end in .sqfs, which is the extension for squashfs images. And that's your hint to Charliecloud that you would like it to use this format. Squashfs images are read-only because it's not feasible to change the contents of a single large file, but read operations are very fast. So it's okay to put squashfs images on the network file system, Scratch. So that is what we are going to do. Let's go to Scratch, cd $Scratch, and make a directory for yourself. I named mine C_tutorial. And then we'll navigate to there. So we have a place in Scratch to put a squashfs image. cd $Scratch, cd C_tutorial. I did this earlier, if you recall. So now I am in my Scratch directory, which is a network file system, which means it is available on both login nodes and compute nodes. And there's that file I was playing with earlier, in case you were around and you remember that part. Does everybody have a chance to go to Scratch directory and set up a little directory for yourself? So now we want to create a squashfs image from our directory format image and put it in the Scratch file system. So we use chconvert. This time the source is our directory format image, temp user alma linux, and the destination is almalinux.sqfs, where the extension here is telling Charliecloud which format to use. And you can see even that only took less than a second. So chconvert the directory format image in the temp file system, and then the squashfs format image, which is in the Scratch file system. So how do we know? Because I'm currently in the Scratch file system and there's my image. So are our changes still there? If you recall, we added a directory to that. We added my dir to that directory format image, and then we converted the image to squashfs. So does the squashfs variant of the image still have my dir? Yes, it does. So when you convert images from one format to another, you get to keep your changes and bring them with you. And don't forget to leave the container to get back to the regular file system. Any questions about squashfs?
So Charlie, yes, the squashfs need to be installed by the administrator as a package, right? In order for
I
it to take it.
recommend, if you're going to do Charliecloud with squashfs, I recommend that the administrators install SquashFS. It is just a standard Linux package, so they shouldn't be afraid to do it. But my experience of building SquashFS on my own in my user directory is that it's very difficult. SquashFS is not meant to be built by users. Charliecloud, totally fine to build by users. I could do that in 5 minutes. SquashFS, I struggled for 2 days and couldn't do it. So definitely ask your system administrators to install SquashFS. Is there any file size difference? That's a good question. I do not know. We can find out. What's the best way to learn? So let's hit the Alma Linux SquashFS with DU, and let's hit the Alma Linux directory format image with DU. And you can see that, I'm sorry, I didn't do it in the best way, but you can see that the directory format image is a bit larger, maybe like a factor of 2 or 3 larger. The SquashFS image is somehow compressed. I don't know exactly. I'm not an expert in SquashFS. It's a little smaller. That's not the main benefit to us. The main benefit to us is because this is a single file, it's okay for network file systems. Network file systems really struggle with thousands of small files. That's why we do this. Delilah suggests use SPAC. I once attended a SPAC webinar where they said that their cute trick is you launch a container, you install SPAC in the container, you use SPAC to install other things, and then you uninstall SPAC in the container, and what's left is a container with like ridiculously complex software, and you're like, how the heck did you make that? It's magic. So yeah, just a fun little aside for Delilah to appreciate. Let us move on to the next file format. Let's talk about Singularity image formats. Like Charliecloud, Singularity container images come in 2 main formats. You have the directory format and you have the single file. Now the single file format is different. Instead of SquashFS, Singularity uses SIF, which is like Singularity image file or something like that for single file images, and that is the default. The tool that we use with Singularity is named Singularity Build, and that is the one that can convert images in both formats. So if you are converting to a directory format image, then you use the sandbox option to specify that the destination will be a directory format. So let's see what that looks like. Wait, don't we have to get back on a compute node? Yeah, we have to get back on the compute node. So in order to do Singularity, we have to get back on the compute node. So this is the same command again. So you can, if you're still connected to the login node, you can just hit the up arrow on your keyboard to find this command again. But we need to repeat these steps. And then we need to return to the scratch area if it drops you into your home area or somewhere else. I can't predict where it will put you. So let's hit up arrow a few times. Actually a lot of times. And here we have srun time mem pty bash. Slurm job queued and waiting for resources. We need a compute node to try out Singularity image formats. So let's do the Singularity cache dir export again. And module load web proxy in case we need to fetch something from the internet. And am I in my scratch area? Oh, I am in my scratch area. So I actually don't need this one this time. Sometimes I need it, sometimes I don't. I can't predict. So I just leave it here just in case. Was everyone able to get onto a compute node and do these steps again? We are on page 40 in the PDF if you are using copy and paste, which I recommend for these because we're not really here to. Oh, it's not 40 in the PDF because I created another slide. Remember, I created this break slide. Get out of here, break slide. We don't need you. So we're actually on page 39 in the PDF. 38. Did I create another slide in here somewhere? Yeah, I remember I did because I created this extra slide up here. Get out of here. We don't need you. Sorry if I've been reading you wrong slide numbers this whole time. I didn't even realize I was doing that. So page 38 in the PDF is where we are. Can you throw a thumbs up in Zoom if you're able to get to the compute node and set up your Singularity variables? Same as we did before. I would like to see, I see 1 thumbs, 2, 3, 4 thumbs, 4 thumbs. 27 participants, 4 thumbs. 5, 6, 7. Okay, I lost count. There's a few thumbs. Let's say we're ready to do the Singularity files. So because we're on a compute node with a new job, we lost our Singularity cache. So yes, we will have to pull the image again. Now let's try a slightly different method. Before we did Singularity shell, which was pull and run at the same time, this time we don't want to run. So instead of shell, we're just going to do Singularity pull. And we're going to specify an image format because we're learning about image formats. So note the order of the arguments. This time is destination first, source second. Why is it different? I don't know. Charliecloud did it one way, Singularity did it the other way. I guess it's a preference thing. So it's Singularity pull destination almalinux.sif source docker :/ almalinux 8. Remember, with Singularity, you do need to specify the URL at least in shorthand. So let's copy that over here. I don't know why it sometimes takes longer with Singularity. Sorry, I literally just don't know why. It may be because we only requested 1 core on the compute node, whereas on the login node, you can actually do parallel things. Okay, the SIF file is ready. So let's see if it's here. We have a almalinux.sif. So straight away, you could run out of that and see that it's a normal almalinux, but we've kind of already done that. So like, we don't need to do that again right now. We can do that in a minute. We're trying to learn about image formats. So let's transform this SIF into a directory format image. So Singularity build -- sandbox means the destination will be a directory format image. Where would you like to put it? We're going to put it in temp dir. Again, this is a location in temp that's specific to this job, so it'll be cleaned up when we're done. That's good because we need to be courteous and not make a mess on the compute nodes. So what was this? Singularity build -- sandbox temp dir / almalinux is what I'm choosing to name this. And then the source will be that SIF that you have here in your Scratch directory. It says it finished. So now we have 2 Singularity images, just like we had 2 Charliecloud images. So we have almalinux.sif, oops, and we have almalinux, a directory format image in your temporary area. Now we can do the same thing in Singularity that we did with Charliecloud. We are able to write to these directory format images, very similar syntax. We have Singularity shell. We previously used Singularity shell to get a process, but this time instead of pulling, we're going to use an already pulled container. Singularity shell -- writable, and then path to the image. In this case, we use the directory format image that we put in temp dir. And we'll repeat the procedure. Make a MITR, and then go back in and make sure it's still there. Singularity shell -- writable tmp dir / almalinux. It complains that Scratch doesn't exist in the container. I can talk about that later, but right now I want to focus on the task at hand. The task at hand was make dir my underscore dir exit. And then we go back in. We don't need the writable flag this time because we're just looking. And we can see that my dir is still there. So now we can have persistent changes in Singularity directory images. Any questions so far? Are you able to follow along? Are you following along and learning about directory images with Singularity and Charliecloud?
I had an error when I tried to build Singularity build. The errors give me, it says error for command build unknown shorthand flag -- sandbox. I'm in compete node C085. And I have a Charliecloud loaded, web proxy loaded.
Okay, so Barry suggests you get an error if you try to copy from the PDF. Can I see what's in the PDF? Is this what you're copying from the PDF?
No, I had singular sandbox, build sandbox. I don't feel, yeah, this is the one.
Oh, I see what happened. That's not the right character. You see, it kind of looks like dash dash. They're slightly different. This is actually like dash. This is actually like dash long dash. That's the right.
Okay.
Oh my goodness. I tried
I'm gonna write
so
it.
hard to make it not do that, but it keeps auto replacing my dashes with long dashes.
Okay,
sorry, guys.
Type it.
Yes, you're gonna have to replace that long dash with another short dash. It's supposed to be short dash, short dash.
Okay, it's working now. That was it.
Yeah, you don't know how many times I corrected this manually and I still one slipped through. I apologize for the inconvenience. Okay, so everybody who had an error is now able to proceed with this. You got the sandbox working and the Singularity shell writable make a change. Okay. I'd like to talk for a moment. We've just learned that Charliecloud and Singularity have directory format images. Are all the directory format images in the world the same format? Let's try an experiment. Still on your compute node, module load Charliecloud. Actually, we might have to unload it first. I'm not sure if that matters. Actually, I don't know. I don't think that matters. Just make sure it is loaded. Module list. Yeah, Charliecloud's loaded. That's fine. So chrun, let's use Charliecloud to run out of the directory format image that we made with Singularity. If you recall, we just made this image using Singularity, and now let's run it with Charliecloud. Boom, my dir is still there. Everything worked great. So according to my quick experiment, directory format images are universal. That's just a file system. All of the Singularity containers and Charliecloud containers and Docker containers and all the different container runtimes agree that it's just a file system tree, so they can all use the same format for directory format images. In fact, you can even use some directory format images that aren't even containers. So for example, if we go to GitHub and go to Alpine Linux has a release, which is just its file tree that you can see if we click on this. Alpine Linux in GitHub has a file tree, not on the master branch, but if you click on any of these releases, you can see there's what happened? Am I confused? Yeah, there's a release here, which is just the whole file tree, but it's not a container. It's just a tar.gz of a bunch of files. It doesn't matter. If it's a bunch of files, we can use it. So let's do an exercise. Navigate to your temp space. We have to do this in temp because it's going to be a lot of small files. So cd temp dir, and then we'll fetch that tarball. So you can use the wget. My experience is copying and pasting these wget commands out of a PDF really sketchy. Like this only works half the time. It's not even my fault. Like I fix it as best I can, still doesn't work, doesn't matter. So I give you the alternative. I already downloaded this tarball and I put it here on disk. So it might be easier just to copy it from disk. So I'm going to do it that way instead. So I'm on page 42. I'm going to go cd temp dir. And I'm going to cp scratch training containers alpine tar xz, and then the last argument is dot for current directory. So now I have that alpine tarball. Everybody able to find the alpine tarball? And you're working in your temp dir, right? The job directory. Please give a thumbs up if you're following along and you have that tarball. So I'm going to demonstrate that it's a tar bomb. You don't have to do this step. Have anyone heard of a tar bomb? That means all the files are in the root of this tarball. So if we unpack the tarball, it's going to dump a lot of files into the current directory. C. Robert says not found. I couldn't find it. I don't know what's going on. I literally copied and pasted this from my PDF and it worked. Okay, typos. Yeah, typos can happen to anyone. Remember, tab autocomplete is your friend.
It worked for me.
Training containers alpine. Like I only had to type like 8 characters to do that. So how do we deal with tar bombs? Well, you just make a directory and you put it in the directory. So I'm going to make dir alpine, and that's going to be the directory where the alpine goes. And a cd into the alpine, and then in here, we're going to unpack the tarball. So the syntax is tar, x for unpack, f for from a file, and then the location of the file relative to your current directory. And now we have that file system tree right here. What can we do with it? What can we do with it? We can run containers out of it. And we haven't even converted it or anything. We just unpack a tarball and we can run both types of containers out of it straight away. So here we have 2 types of containers. I don't feel like I need to demonstrate this one because it's just like things we've done before. But so you can do this as an independent exercise. Go ahead and run either or both of these container runtimes out of your Alpine image and use, for example, cat etc Alpine release to verify that you are in fact in the Alpine image. And you can see that, okay, so the one hiccup is because Alpine doesn't have bash, when you do chrun, you have to pick bin sh manually as a shell that's actually present in there. But with Singularity, you don't have to manually pick it. The Singularity shell was able to figure out what to do. So that's the only difference here. And that only even matters because Alpine is so small that it doesn't even have bash. So sad. Would anyone like to throw the thumbs up in Zoom if you have done either of these 2 tests to verify that you can run containers directly out of that tar bomb from GitHub? Janel says he's done it. Robert says he's done it. I see some more thumbs up. Barry, Jose. Tom, I can't tell whose thumbs were already up or down. Sorry, some people may have left them up from previous exercise.
So, Richard, I have a fundamental question. On your last, it's going to be unfair for other users. Last tutorial, you said the difference between Singularity and Charliecloud is you, in order to write something on the root, you have to root permission for Singularity, but not for Charliecloud. But
so the short answer is that is no longer correct. It was correct in the past. So I was teaching slightly outdated information.
Okay.
This is the up-to-date information. The up-to-date information is Singularity can do the same things Charliecloud can do. So the difference between them is, at this time, as far as I can tell, mostly preference. There are still differences between them. For example, Charliecloud has new features that Singularity doesn't have yet, and Singularity has features Charliecloud doesn't have yet. But like the fundamentals are the same. They're both fundamentally capable of doing all these things. You're just debating over small features like what's easier. I apologize for any misinformation I may have given you in the past.
No.
I have, with these ecosystems evolve quickly, and not everyone is always up to date.
No, I didn't mean to catch you. But so if I want to install Charliecloud, I'll have Singularity in my cluster. Tell me just one example, one benefit from both of them that having two on the
Sorry,
same
what was
cluster.
the question?
So I have Singularity on my cluster. Most of the cluster tasks come with the default. Having, you said both of them has features, the other one doesn't. Can you give one example that is important?
An important feature?
Yeah, for both.
So Singularity can automatically mount the GPU drivers, and Charliecloud, you have to manually mount the GPU drivers. So it's slightly more work to do that task with Charliecloud. They can both do it, but Singularity has an advantage there. Another example is Charliecloud's build strategy is a bit more advanced. So there are a few corner cases where you can build something in Charliecloud that you can't build in Singularity as easily. But those are corner cases. Like the majority of cases, they both build fine. So Charliecloud can handle some of the corner cases better than Singularity can, as far as building images from scratch. And unfortunately, I'm not enough of an expert to explain what those corner cases are. But if you attend the Charliecloud user group meetings, which are the second Tuesday of every month, they're always going on and on about how cool it is that they can do this thing now. So I'm sure they'd love to tell you more about it. It's one of the new features. We do have one more topic today, which is container recipes. So far, everything we've done with containers has been manual. We are manually making each change to the container. But that's not the best strategy, because then after you've manually changed your container, the information about what steps you took is lost. You're the only one who knows what is in that container. So better practice would be to write down those steps in a recipe file. And all the container runtimes have a way to do this. So Docker uses a recipe file named Dockerfile. Charliecloud supports Docker files, so the same syntax. Singularity uses a different recipe file called a definition file. Different syntax, but for the same purpose. It's essentially writing down the steps that are taken to build a container image. And although I don't have a lot of time left, I would like to teach you one or both of these. We'll definitely have time for one. I don't know if we'll have time for both. We'll see what happens. So let's describe a target recipe. Richard Lawrence would like to put Python in a container and also a Python script, both. Because, what's the point of having one without the other, right? So in order to install Python normally on a Red Hat flavor of Linux, you would use Yum. Yum is the package manager for Linux, for Red Hat flavors of Linux. So it would be Yum install Python. Oops, that's a typo. It's meant to be Python 3.9. I apologize. Can you mentally in your head change that to 3.9? So Yum install Python 3.9. And then we would also like to have a Python script. I'm just going to do hello world. So a Python script might look like hash bang usr bin python 3 print quote hello world. If you're familiar with Python, you will not be surprised. This is a very simple Python script. And then, of course, if you want to execute Python scripts, you have to change their permissions to executable. Now, all of these steps might be a hassle to do on bare metal. For example, installing Python on bare metal, a hassle. So it's much better to let Yum do it for us, but we need permission. And so that's where containers come in. They can help us with the permissions. So let's learn about how you would do these steps using the Dockerfile syntax for recipes. This is the same thing. This is the recipe file syntax that Docker and Charliecloud have in common. So we have a from statement. The from tells us a base image that we're building off of. Always build off of base images. Let someone who's the expert build your base image. You just extend them. Next, we have the run command, which says inside the image, execute this. That will install the software. We can do it manually. You can go, ch run bash, and then in the container run yum install Python. You could, but we're trying to learn how to do that with a recipe so that we have a record of what's been done, so that we can repeat it. And then we have the copy statement, which moves a file from outside the container to inside the container. So we can create our hello.py on the compute node in the real file system, copy it into the container, and it can be in the root directory of the container. And then we have another run command to set the permissions for hello.py to make it into an executable. Are there any questions about these three types of statements, the from, the run, and the copy statements in a Docker file? Has anyone here seen a Docker file before? Perhaps you previously used Docker on your personal machine and you've seen a Docker file before. Go ahead and let us know in the chat if you have some experience or if you don't. If you don't, that's okay. We can just do some copying and pasting for now. So the Charliecloud recipe, we're going to have to put these files in a space. So let's set up a workspace. It's just a directory where we're going to put some files to stay organized. The directory is not special. I chose to name it hello source Docker because we're using Docker as the source of an image. And we need two files. We need a hello.py and we need a Docker file. So do take a moment to create these files by one method or another. You can use vim from the command line. You can use it. Let's see, I forgot to specify. I recommend that you do this in your Scratch space. If you do this in your Scratch space, then it doesn't matter because Scratch is a network file system. It exists on all the nodes. Now, everything we're going to do right now, it's going to be single image files. So we don't need to be in the temp system. We can do this on the Scratch system. So yes, please, I think you're still in your Scratch area because that's where we were a moment ago. We'll just do this in the Scratch area. You can use the Vim. You can use the dashboard files menu. We previously played with that. Or you can copy from my training area. I made a copy of some of these files in my training area. Oh, we're not in Scratch. We were in temp space. I apologize. I'm returning to Scratch. C_tutorial. Okay, so I'm actually going to copy I'm going to copy the files out of my training directory because I made some copies earlier and they're available. So ls scratch training containers See, there's those two directories, hello.source.docker. So I can copy that stuff here. Ta-da! I set up hello.source.docker. There's a Docker file and there's a hello.py. And I can do the same thing for the definition one. We'll learn it in a second. We'll learn that in a second. So I've just copied them. If you want to make them by hand, by copying and pasting, or in Vim or something, that's fine too, if you want to practice. Does anybody want more time to set up these files, or are these files already set up? Or maybe you just don't feel like doing the exercise. If you do need more time, please ask for more time. Otherwise, I'll assume that you either have already done it or you're not going to. So let's learn how to use Charliecloud to build an image from a recipe. So we have the chimage build tool, and it has a couple of arguments. The -t argument is what would you like to name the image? The -f argument is where is the recipe file? And the dot argument is what is the context directory? The context directory is usually the same directory as where the Docker file is. That's the directory where the things needed to build the container image are to be found. So we will need hello.py. It's in the current directory. So we tell chimage, everything you need is in the current directory. We have to cd into that space where the files are, hello.source.docker, and chimage. See, actually, I'm gonna reload Charliecloud just in case. Oh, and we need web proxy. You don't have to reload your modules, I don't think, but I decided to. So let's do chimage build -t hello -f docker file dot for current directory. Because we're on a compute node, we had to pull the Alma Linux again. And now we are installing Python. See, it's Python 3.9. The slide was meant to be 3.9. It says complete, and then it says hello. So what can we do with our image? Well, currently it's in the chimage storage dir, so let's convert it to a squashfs. Because we installed Python, it's quite a bit larger, so that's why it's good that we're on a compute node. We know we're not using more resources than we need to. You can see that Charliecloud would happily use the whole node. On a login node, that's like a faux pas. Don't use up the whole login node. But here on a compute node, you just use what you're paying for, so it's no big deal. So now we have hello.squashfs. And what can we do with hello.squashfs? Well, let's execute that hello.py that, if you recall, we copied into the directory. Permission denied. What is permission denied? Okay, so if you navigate back to your own Scratch area, then you can make the squashfs. What can we do with the squashfs? chrun, except instead of a terminal, let's just try to execute hello.py. It says hello from Python, because that's what I wrote in my example. I didn't show you what was in there, but that's what was in there. Hello from Python. What else can we do? Let's check to see what version of Python is in the container. So if we do chrun hello.sqfs, the executable is Python 3, and we'll pass in its version flag. So we'll say, hey, Python, what version are you? I'm 3.9. That's the one that we requested in the Docker file. For interest, what version of Python is available on the compute node? Python 3.6. So that's a different build of Python. So now we know that we can install Python in a container image and have a different version than what's on the compute node. That is the end of the exercise for Docker files. Does anyone have a question about these Docker files?
Yes.
Okay, some people say yes. People want to spend the last few minutes and do the last activity. It's the last activity, I promise. So let's learn about the definition files. The definition file is a different syntax for recipes that is used by Singularity. So here's what a definition file might look like. We have the bootstrap statement, which says, where does the base image come from? So if it's bootstrap Docker, that means the base image is coming from Docker Hub. From is the name of the base image. So we're grabbing Alma Linux 8 from Docker Hub. So that's what these two lines are doing. Now, Singularity definition files are organized. They're not organized chronologically, so to speak. They're organized into sections. So we have the %files section, and every line that you write in the files section is a file that will be copied from outside the container into the container. The default destination is the root directory. So you see, I haven't put a destination. That means use the default, and the default is in the root directory. You can also specify a particular location by having it in here. Then it's source space destination. You also have a post section that starts with %post, and post means after you build your base image and copy files into it, then run these commands in the container. So we're going to run the yum install Python command, and we're going to run the chmod on the hello.py, which now is in the root. So roughly speaking, post happens after files, but not because of the way they're ordered in this document. Singularity does its own internal logic to determine the order in which these events happen. So let's take a minute to set up these files. It's the same hello.py we had before, but this time we're using Singularity definition file. You can use copy and paste from the PDF, or you can copy from the training directory, which I did earlier. So if I navigate out of that Docker area, I can navigate into the definition area. We can see I have a definition file. There it is. I'm installing Python 3.9. Would anyone like a minute to set up this workspace? Okay. C. Roberts would like a minute to set up the workspace, so we will wait a minute. Yeah. So if we go to the next slide, once you have your definition file, you go into the directory where the definition file is, and then we're going to use Singularity build to build a container from the definition file. Recall that the order of the arguments is different than Charliecloud. It's destination first, source second. And fake root is an option that is needed for Singularity that was not needed for Charliecloud. So in Charliecloud, fake root is like the default. But in Singularity, fake root is not the default. They're the same fake root. In fact, Singularity got it from Charliecloud. Charliecloud says they're very proud of that. So in Singularity, you have to specify you want fake root. So what does fake root do? Yum needs to do a couple of things. Obviously, we know it needs to put files where they belong, right? Now, since in the image, you own the file tree, it's just regular files, right? Yum definitely can put those files where they belong. If it just tried, it would succeed. But Yum is designed to be more intelligent. So it isn't just going to blindly copy files. First, it's going to try some tests. It's going to say, let's test to see if I have permission to copy files. And what it's going to do is it's going to ask the kernel, am I root? Am I allowed to install things? And the kernel normally would respond back, no, because the user didn't type sudo. So in order to even persuade Yum to proceed, we need to intercept that call that says, hey, kernel, am I root? And replace it with, yes, you are root. Go ahead and proceed. So that's what fake root is doing. It's basically intercepting Yum doing its tests to see if it has permission to install and telling it that it does so that it will try, which as soon as it's willing to try, it will immediately succeed because in the image, all the files are just owned by you. So there's no actual permission problem. There's just like a perceived permission problem. Did I answer your question?
Yeah, so remember last time you said, oh, you know what? I taught you something wrong. Charliecloud has updated. He did not taught something wrong. Here's the fake root, proved it. In Singularity, you need the fake root to become root, right? And where Charliecloud, you don't need that.
I don't know everything about how Charliecloud and Singularity work inside. I know how to use them. I'm not a proper developer. So it's possible I say things that aren't totally accurate or not totally helpful. Once you surpass me in knowledge, I'm sure you'll be able to tell me what I did wrong. But hopefully for the people who are just seeing containers for the first time, this is helping you understand what's possible.
Oh, no, you didn't wrong it. I was just supporting your statement that you said it right in the last.
Okay, so I'm going to try the exercise, singularity build -- fake root. The source comes second, so the destination comes first. The destination will be hello.sif and the source will be the definition file. Oh, a Singularity remembers that I previously downloaded Alma Linux, so it skipped it. Isn't that cool? Was everyone able to use Singularity build with fake root to get an SIF, Singularity image file? It does take a little longer. I don't know why it sometimes takes longer and sometimes not. That means the last thing, the literal last thing we're going to do is test that SIF file to see if it's got Python in it. So previously we used Singularity shell to get a bash. This time we don't want a bash. So we're going to use Singularity exec, which means instead of bash, you decide which executable. So the syntax is Singularity exec image executable. So we're going to execute our hello.py script. Then we're going to execute Python with the version flag to see what version is installed in there. And in case you forgot, we can check on the local node to see if it's the same or different. So it's Singularity exec hello.sif / hello.py, hello from Python, Singularity exec hello.sif Python 3 -- version, says it's version 3.9, but again, on the compute node, what's installed is Python 3.6. So now we know how to write a definition file to install software into an image in a Singularity format that could be different software than what's on the compute node. And that is all of the exercises that I have for you today. So I would like to show you my acknowledgement slide. This work was supported by the National Science Foundation. Award numbers, we have the ACES Award, which paid for the computing cluster we've been playing with. We have the Sweeter Award, Southwest Expertise in Expanding Training, Education, and Research, which paid for some of the training development and my time training you today. Faster is our other flagship cluster at A&M, so some of the development work was done back when we were doing it on Faster instead of on ACES. We have staff and students at A&M High Performance Research Computing. For example, our very nice system administrator, Francis, who helped to get us onto the compute nodes today, and our very nice director of enablement, Lisa Perez, who helped to get everyone their accounts on ACES today. And finally, I'd like to acknowledge the ACCESS CSEP pilot program, Tier 2, which awarded a grant, not for this training, but for a similar training with some overlap. Everyone who attended the training a couple weeks ago probably remembers that there are some overlapping elements. So for those parts, thankful to the CSEP pilot program, they provided a travel grant. So someone, it's me, is going to get an expenses paid trip to the supercomputing conference, where I hope to meet some people who are interested in containers. And I ran out of words to say about that. So when you need help, if you're an ACES user, you can use the ACES service desk, which is an Atlassian product. Or you can send us an email to our help desk directly, which we use a different software internally, but that doesn't matter. For you, it's just an email. So you send an email for a ticket if you need help with something more technical, or if you need help with something that's more access related, then you would go to the ACES service desk and submit your ticket there. And if, of course, whenever you're asking for help, please be specific so we understand how we can help you. I think that's the last slide. Yay, I finished.